Welcome to the next session, my dear friends. In the previous session, we have discussed up to the question number 5. So we are discussing the rest of the questions in this session. So question number 6, it is GATE 2015. One more question from set 1. One more question from set 1. So let us read the question first. So now here the question is like this: solid waste generated from an industry contains only two components, X and Y, as shown in the table below. So components proportions are given. Assuming C1 plus C2 is equal to 100, the composite density of the solid waste rho is given by composite density of the solid waste they want. Okay. So what is the given data? So component, the given data is this. Component given, so proportion given, percentage, weight, okay, and the density is given. So what is the component? X and Y, two components are there, and their compositions are C1, C2, and their densities are rho 1 and rho 2. So I already told you in the previous sessions, when composition and their densities are given, what is the formula we need to use to find the density of the composite material? Means what composite means? It is a mixture of 2 or 3 different materials. That is nothing but solid waste. So the density of the solid waste is nothing but is equal to proportion of A by rho of A plus proportion of B by rho of B, and so on, like that I have already told you. So here only two items are there, so we need to take up to B only. So proportion of A is how much? C1, and A density is rho 1. Proportion of B is C2. So density of B is rho 2. So this is nothing but 100 by rho. So this is given as rho. Okay, this is given as rho in the question. So this rho is equal to, I will take this rho on this side and bring this total one as a denominator to here. Okay. So now it is equal to, that implies 100 by C1 by rho 1 plus C2 by rho 2 is equal to rho. This is simple. That's it. This is the answer. This is the answer. Okay. That is the sixth question solution. So let us go to the next question. That is question number 7. So let us go to the next question. Question number 7. Question number 7, GATE 2017, 2 marks. GATE 2017, 2 marks, and from set 2. So the question is like this: the composition of municipal solid waste, the composition of municipal solid waste sample is given below. So component wise proportions are given, and their moisture is given and energy is given. The difference between the energy content of the waste sample calculated on dry basis and as discarded. This is the question. This is the question. Simple question actually, but lengthy question. Not a tough question. Simple question, but lengthy question. So what is the given data? So component, percentage by mass, percentage moisture, and energy content, kilojoule per kg, as discarded. As discarded. So the components: food waste, and paper, food waste, paper, cardboard, plastics, cardboard, plastics, garden trimmings, wood, tin cans, wood and tin cans. So these are the different components present inside the solid waste. Percentage by mass: 20%. Okay, next is 10, 10, 10, 45, 5. 10, 10, 10, 40, 5 and 5. So these are the proportions by mass. Percentage moisture: 74, 4, 1, 74, 4, 1, 60, 22, 60, 20 and 2. So energy content as discarded: 2500, 10,000, 8,000, 8,000, 14,000, 3,500, 14,000, and 100 and 100. So these are the energy. This is the given data. This is the given data. What he is asking is the difference between energy content on dry basis minus as discarded. So that is nothing but simply, if he is asking, this is energy content on dry basis is what? 100% by, okay, so energy, if the energy as discarded is E, if the energy as discarded, let us take the energy as discarded is E, okay, then energy on dry basis is nothing but 100 into E by 100 minus moisture content. This is what I have told you in the previous sessions. So this is energy content on dry basis. This minus E again. So that means he is asking the difference. So the difference is equal to 100 into E by 100 minus moisture is nothing but mass content, percentage mass. That is nothing but percentage mass only. Okay, anyways, let us take it as 100 minus moisture only for a while. 100 minus moisture content minus E. So that means E, if I take it as common, 100 by 100 minus moisture content minus 1. So E into, so if I take it as LCM, minus 100 plus moisture content by 100 minus moisture content. So this 100 cancels. So E into, the answer should be E into MC by 100 minus MC. This should be the answer. So for every material we need to find this. For every material we need to find this. But before doing that, before doing that, actually here this is the energy. If that mass is 100%, that means here whatever be the mass, so if you are taking 1 complete kg of solid waste, this is proportion, it was given in a proportion, and this is the energy when the solid is 100% present. This is the energy when the solid is 100% present, but here the solid is not 100% present, it is only 20% present. Then if this is the energy for 100%, what is the energy for 20%? Are you getting the point? So first of all, we need to find the energies for the given proportions. What is the energy for the given proportions? If it is 20%, then 20% into 2500, that is the only energy that will give, that is 500 energy it will give. Are you getting my point? So here it is 2500 for 100% presence, but here it is present for only 20%. So the energy as discarded for these proportions will be different. Energy as discarded for these proportions will vary. So first we need to find the energy content for these proportions. Let us first take a table again. So this is our formula. Now first we need to find E. So I am doing that, E. And moisture content is present with us. So simple. Once E is there, then the difference can be directly calculated by multiplying it with the factor, that is MC by 100 minus MC. Are you getting my point? So let us first do that. First find E. So this formula I will write it at the top. So the difference E into moisture content by okay, this is the formula. Now, so energy content as per proportions. As per proportions. So here the proportion is 20%. So 0.2, that means let us take the numbering 1, 2 and 3. I name it as 1, 2, 3 column. So column 1 by 100 into column 3. So this is the energy content as per proportion. So 0.2, 20 by 100 into 25, that is 500. Similarly here 10 by 100, that is 0.1000. Here 10, 800. Okay, so here it is 10 by 100, 1400. So 40 into 3500, how much it is? Again it is 1400 only. And 5% of 14 5 ja, 5% of that is 700. Here 5% of 100, that means 5. 5% of 100, that is 5 only. So now this should be multiplied with MC by, so this is their MC factors. Let us calculate the factors now. So the difference will be equal to, so let us take this column as 4. 4 multiplied with 2 by 100 minus 2. So simple, 500 into 2 is how much? 70 by 30. Okay, this is, so if we calculate this, we will get the answers. First I will write the values. 1000 by 96. This is 4. Moisture content is 4. Four by 100 minus 96. Here 800 into 4 by 96. 1400 1 by 99. This is the difference directly. That 1400 into 60 percentages of moisture. 60 by 40. 700 into 20 by 80. 5 into 2 by 98. 5 into 2 by 98. So if you solve this, we will get the answer. If we solve this, we will directly get the answer. Let us do it. So 500 into 70 by 30, that is 1166.67. 1166.67. So these are the values. These are the values of this, and the difference is equal to 3530.91. So this is the accurate method. This is the accurate method. There is another method, that is approximate method. There is another method, that is approximate method in this. So that approximate method is like this. See, here this is add this completely. So this is energy content as per discarded. If you add this, you will get the value as 5805. So you will get the value as 5805 kilojoule per kg. So this is the energy as discarded as per the proportions. Now if you look at the moisture, and from here I can find the solid content. So if you deduct 100 minus moisture, then it is called dry content. Okay, so we will get the dry content. So if you see the dry content here, so the dry content, if you see 70, that is 30, 4, 96, this is 96, 1, that means how much? 99, it is 60, 40, 20, 80. So this is the dry content. Okay, this is the dry content. So this is the dry content 30%, but it is having a mass per proportion of 20%. Then we will get the dry content proportion. Okay, so as per the moisture it should be 30%, but as per the proportion it is 20%. If you want the exact dry content, that means, see, if you take 100 kg or 100% of that material, so 30% will be the dry mass, and in this 30%, only 20% is going into the solid waste. Are you getting the point clearly? See, I am telling you. Here, some solid mass is having 100 gram. Okay, some solid mass is having 100 gram. In this, 30 gram is solid and 70 gram is water. Okay, So now this is not 100 gram in the solid waste. It is not 100 gram now. It is only 20 gram. In the solid waste, if you see, this is solid waste. So in this solid waste, this is also present. This solid is also present. So this solid here it is only 20 gram. So for 100 gram, this is 30 gram solid. For 100 gram, the solid is 30 gram. Now if it is 20 gram, that means if it is 20 gram, then 30 by 100 into 20. 30 by 100 into 20, that is nothing but I am saying this is 20 into 30, that is 0.6 by 100. If you do by 100, that is 0.6, 0.2 into 0.3. This is the mass present in the solid waste. Mass present in the solid waste. That is what I am saying. So now the mass present inside the solid waste. The mass present inside the solid waste. So dry content, that is called dry mass. Dry mass proportion is equal to 0.2 into 0.3, that is 6 plus 0.1 into 0.96, that is 9.6. So this is 9.6 plus 0.1 into 96, that is 9.6 again, plus this is 9.9 and this is 0.4 and 40, that is how much? 16 plus 5 into 80. 5 into 80, how much it is? 4.05 into 80, that is 4 plus 5 into 98, how much it is? 4.9. This is 4.9. So this is equal to 60. It is coming 60. So dry mass proportion is only 60%. Dry mass proportion is 60%. Clearly understand what I am saying, what I am doing here. So this is the energy given for 100 kg of combustion. So if you are taking 1 kg of this material, if you are burning 1 kg of this material, this much kilojoule will come. But here it is not 1 kg, it is 20% of 1 kg is present. So that is why the 20% of 1 kg's energy content is this much. That means 20% of this. These are the energies. These are the energies for the given proportions. Similarly, so this is the proportions when it is 100%. So if it is food waste is 100%, in that food waste 70% is water, 30% is food, the dry food. But here again, this is 100% for this food waste. But when you go to the solid waste, so this is only going 20% there. This is going only 20% there. That means from this 100%, 20% of moisture is going, 20% of this food is going. 20% of the food is going. Similarly, 10% of moisture is going, 10% of dry content is going. 10% of moisture, 10% of dry content of cardboard. Like that, every material is going that much proportions only. Every material is going this proportions out of these 100%. Now if you look at the mass, dry content is this much in 100%, but in the proportion of for this proportion in the solid waste, this is the dry proportion, that is 60%. That means 40% is the moisture. So here I have did this for each and everyone separately. For each and every material separately I have did. You can do it directly from here also. So 5805. So all together at a time. So I am taking uniform values. All together I am doing it at a time. I am not taking them separately. Now here the difference is energy 5805 So if 60 is the dry weight, then what is the moisture? 40 by 60. Simple, 40 by 60. This is the answer. 5805 into 40 by 60. That is the answer. So if you do this, then also you will get approximate answer. That is 3870. That is 3870. 3870. So this is an approximate answer. This is exact answer. So that is the difference. Okay. Anything you can take. So the marks will be given. But I prefer to go with this method because in GATE this much time will not be available for us. So approximate answers will take less time, and also we will get the marks. So that way choose the shortest path. Choose the shortest path. So that will be the better one. Okay. So this is the question number 7. Let us go to the next question. So this is very lengthy question. Actually, I suggest you not to attempt these kind of questions in the beginning if you are getting sufficient time, because it needs lot of thinking also. So if you are getting sufficient time, then only attempt these kind of questions, because studying this question itself takes at least 1 or 1.5 minutes. Okay. So that is why. So don't prefer these kind of questions in the beginning. Do it at the end. And these kind of questions hardly come. Somewhere, sometime it will come, but it will be difficult to everyone. Not only you, everybody will face the same difficulty. But this is not that difficult question if you understand the concept clearly. So this question is not that difficult. You need to understand the mechanism, how this is happening, solid waste and all, how this energy is coming, how these proportions are going into that. So if you understand that sequence mechanism, then it is very easy to understand anything. So next question, 8th question, 2018, 2 marks. A coal containing 2% sulfur is burned completely to ash in a brick kiln at a rate of 30 kg per minute. The sulfur content in the ash was found to be 6% of the initial amount of sulfur present in the coal fed to the brick kiln. The molecular weight of sulfur, hydrogen, oxygen is 30 to 116 gram per mole respectively. The annual rate of sulfur dioxide emission from the jute kiln in tons per year up to 2 decimal places. Very simple question and very good question. So given, what is the given data? What is the given data? A coal containing, so sulfur content in the raw coal. Okay. So sulfur percentage in raw coal is 2%. And sulfur feeding rate. Sulfur feeding rate is 30 kg per minute into the brick kiln. 30 kg per minute in the brick kiln. The sulfur content in the ash is 6% of the initial amount. 6% of the initial amount. So the emission, the annual rate of SO2 in tons per year. So what is the sulfur present initially in the raw coal? Okay, so that is, so sulfur content in raw coal or fresh coal or unburnt coal is 2%. Okay, so first of all, I want this in per year. Simple, very simple questions. These are all. I want this in ton per year. Okay, I want to convert with the given data. I have to extract a figure that is tons per year. So kg per minute. So this can be converted into ton per year easily. Simply we can convert this into ton per year. Convert this into ton per year. So how much we are sending, how much sulfur is feeding into the kiln? That is 30 kg per minute. If this is 30 kg per minute, then how much for a year? So 30 into kg. So I will convert this kg into ton by multiplying it with 10 to the power of minus 3. So then it will become ton. Okay. And minutes, I can convert this minutes into year by dividing this minute with, so how many minutes? 60 minutes a hour. So 60 minutes is an hour. So 2 into 30 into 10 to the power of minus 3 tons, okay, by year. If I convert this minute into year, I need to multiply it here 1 minute. 60 minutes is an hour. Okay, 60 minutes is an hour and 24 hours is a day and 365 days is a year. So now this is this is 2%. 2% means 2 by 100. So this is the content of sulfur inside the raw coal. So what is the value? This is now ton per year. We got this in ton per year. What is the value of this? 2 by 100, 30, 60, 24, 365 into 10 to the power of minus 3. That is 315.36 tons. 315.36 tons. Okay. So this is the initial amount. In this initial amount, what is the sulfur content in the ash? So that is, sulfur content in the ash is how much? 6%. So sulfur content in ash . 6 by 100 multiplied with the initial content, that is 315.36. So this is how much? What is sulfur content in the ash? It is 296. So a 189, it is equal to 18.6 by 100. 6 by 100 into 1 second. 6 by 100 into 18.92. This is equal to how much? 18.92. So now this is a sulfur present. So this is a sulfur in the raw coal and this sulfur present in the ash. The rest of the sulfur has become the sulfur dioxide. So whatever the sulfur difference you are getting, that has become the sulfur dioxide. That means 315.36 minus 18.92, that is 29.6 tons. So this is the amount. 296.4 tons has become evaporated. So that went out. So sulfur consumed is equal to initial amount minus residual amount, that is 315.36 minus 18.92, that is equal to 296.4 tons. 296.4 tons. This is the sulfur consumed. So the consumed sulfur will convert into sulfur dioxide. So sulfur dioxide means S plus O2 is nothing but SO2. Okay. So what is the weight of sulfur? It was given 32. This is also 32. Okay. So this is also 32. This is also 32. O2 is 32. So 32 of sulfur produce 64 grams of. So 32 gram. So 32 gram of sulfur produces 64 gram of sulfur dioxide, SO2, sulfur dioxide. 32 gram of sulfur produces 64 gram of sulfur dioxide. Then 296.4 tons of this is simple, double. So 296.4 into 2, that is 592.88. So this is the answer. This is the answer of question number 8. This is the answer of the question number 8. So let us discuss the next question. Question number 9. So only 2 questions left. So question number 9, GATE 2018, 1 mark and set 1. So the question is like this. A city generates 40 into 10 to the power of 6 kg of municipal solid waste per year, out of which only 10% is recovered, recycled, and the rest goes into landfill. The land has a single lift of 3 meter height and is compacted to a dry density of 550 kg per meter cube. If 80% of the landfill is assumed to be municipal solid waste, the landfill area required would be in meter square. So this is the question. So what is the given data? Given that the MSW generated is equal to 40 into 10 to the power of 6 kg by a city, out of which only 10% is recovered. So recovered, recycled proportion is 10%. And the rest will go into landfill. The landfill single lift, it is a single lift landfill having height. So landfill height is 3 meter. Landfill height is 3 meter, and the compacted density is how much? 550 kg per meter cube. Kg per meter cube. If 80% landfill is assumed to be proportion of MSW in compacted landfill, that is 20% is cover. Okay, so this is the given question. And what is the surface area needed? Area of a landfill needed in meter square. So this is the question, simple question, very simple question. So this is the MSW generated. Okay, so in this 90% is going into the landfill, 10% is recycled. So now what is the MSW going into landfill? That is 0.9, 90% of this, 40 into 10 to the power of 6 kg. Then what is the volume of the landfill now? What is the volume? The density is given. So volume of compacted MSW, it is equal to how much? Compacted MSW is 0.9 into 40 into 10 to the power of 6 kg by the density, that is 550 kg per meter cube. Now we will get the volume of the compacted MSW. We will get the volume of the compacted MSW. But this volume, if you look at the total MSW, this is kg per year. City generates per year. This is kg per year. This is also per year. Okay. So the volume of the compacted MSW, we will get it as volume is equal to 65454.5454 meter cube per year. So this is the volume needed, but actually this is only 80% volume. So in this volume 20% is volume of cover. Okay, 20% is volume of cover. So here for the total volume, if the total volume of a landfill is taken as V. Okay, so this is what? This is 80% of the V. So 0.8 into V is equal to 65454.5454 meter cube per year. That means this V is equal to 654 0.8. So if you do this, we will get the total volume of the landfill we will get. Total volume of the landfill we will get, that is equal to 81818 0.18 18175 meter cube So this is the total volume. Okay, so now you know the depth. Landfill height is given 3 meters. So what is surface area? So surface area is nothing but area of the landfill is equal to So this is the answer. So how much it is equal to? 27272.7. 27272. 27. So this is the answer of the question number 9. This is the answer of the question number 9. Let us go to the last question of this topic. Question number 10, that is 2019. 2 marks. So here the question is like this, very lengthy question, long question. raw municipal solid waste MSW collected from a city contains 70% decomposable material that can be converted to methane. The water content of the decomposable material is 35%. An elemental analysis of the decomposable material yields that the following mass percentage: carbon, hydrogen, oxygen, nitrogen, other proportions are given. The methane production of the decomposable material is governed by the following equation. The equation was given. Given atomic weights were given. The mass of methane produced in grams. So here it's a very simple question, but little thinking is needed. Okay, lengthy question, again lengthy question. Okay, so what is the given data first? Raw municipal solid waste collected from a city contains 70%. What we will do, this video is becoming very lengthy, so we will discuss this question in the next session, because again 20 minutes or 25 minutes will take this question. So we will discuss this in the next session. Thank you so much.